The red planet. Fourth rock from the sun. 54.6 million kilometers from Earth. For centuries, the planet Mars has been a subject of Earthling fascination. Now, with NASA's Mars 2020 rover mission underway, we are closer than ever to unraveling some of the mysteries of the red planet. Specifically, is there life on Mars? On this episode of Innovation Hall, we visited Siena College physics professor Tom Kuhil, who's working with NASA to find out. So can you see Mars?
Yes, of course. Yeah, you can see Mars very well. Mars is normally a tan orangey color. If it's having a dust storm, it's reddish.
In July of 2020, NASA is sending a new rover to the surface of Mars. The mission? To collect data. The goal? To find evidence of life. So, when I met biophysicist Tom Kuhil at Siena College's Brea Observatory, I had to ask, is there life on Mars?
If you'd asked me 10 years ago, I would have said probably not.
But now?
Probably yes. Probably yes. I didn't say yes. I said probably yes.
Professor Kuhil's mind changed after he got a call from NASA's Jet Propulsion Laboratory last year. They needed his help on the Mars 2020 project.
For the first time, we're going to be able to bring samples back from another planet.
The Mars rover will be digging into the surface of Mars to collect soil samples. Then they'll be packaged up and shot to Earth for study. That's where Kuhil's expertise in ultraviolet sterilization comes in really handy.
What I would do is advise them on the enormous amounts of ultraviolet and what that will do to sterilize any of these samples that we're going to bring home.
Ultraviolet, or UV, falls on the spectrum of light between visible light and X-rays. You can't see it, but if you've ever had a sunburn, you know you can feel the effects of it. The sun is the biggest source of natural UV light in the solar system. On a molecular level, UV light can disrupt a molecule's structure. Because of this, it's effective in sterilizing material. Shortwave UV light is commonly used for food and water sterilization. In this case, it'll be used to ensure that the Mars samples are not contaminated by anything on their trip to Earth.
Because what we're going to do is we're going to have these samples, which, as you see, are going to be in these tubes here. And then we're going to place them in this canister here. And that canister will fill about the size of a basketball.
As the canisters are rocketing back to Earth, they'll be blasted with UV sterilization in various ways that Kuhil has recommended.
So part of my job is to calculate how much that is and how organisms respond to that, how viruses respond to that, all different forms of life, and make sure that that basketball is completely sterile when it comes back to Earth. We think we can do that to a level far beyond any sterility you see in a hospital even. And once we get it home, we open it up in a sterile environment and we take those tubes out and we start looking for life.
But the voyage back to Earth from Mars will take 12 years.
I'll be 90 years old. They'll have to wheel me in a wheelchair.
Kuhil is looking forward to the July 2020 rover launch. In the meantime, he'll continue to admire the red planet from afar. Support for Innovation Hall comes from the Bender Scientific Fund of the Community Foundation for the Greater Capital Region.